Dear student, in this video I'm going to talk about the very important chapter from your exam point of view, chapter transformer. Okay, so I have highlighted few points here to put your attention to this part. So it has been asked in O-Level 2020 and you will see almost in every O-Level paper. Definitely it is a part of MCQ. If you look your question, it will be around 39 question number 39 to 40. There will be a question always from transformer. So why to lose even single marks from MCQ, and also obviously the major portion from the section A and B. So I'm going to simplify here the transformer and also what is the step up and a step down transformer. So let's look out in a bit detail. So this is again to put your attention that it has been asked in O-Level 2020. You can check your paper. This is from pure physics. Okay, so very important topic, let's discuss. So this is based on a principle called Faraday's electromagnetic induction. If you have not watched my previous video regarding Faraday electromagnetic induction, please go and watch, because I have simplified the Faraday's law of electromagnetism and also the Lenz's law. Okay, so please go and visit that. So what is the Faraday electromagnetic induction says? It suggests that if you provide electricity in one coil, okay, and that coil is wrapped on a iron ring, which is a soft magnetic material which can magnetize and demagnetize very fast, and another coil is wrapped in the same magnetic material, means same coil. So if you provide the current in coil A, you will see the induced current in coil B, and this was a very big discovery. And given the discovery of transformer, that wow, it's good. If you're providing one electricity here, you can get same kind of electricity in other coil also without doing anything. You just required a good magnetic material. So what is transformer? You might have definitely seen near your house. It is a passive electrical device. Remember why it is passive? Because here electrical energy is not generated. Okay, this is just a transformer which transfer the electrical energy from one circuit to another through a process of electromagnetic induction, and it is mostly used to increase up, which is called a step up, or decrease, step down, voltage level between the circuit based on your requirement. You remember that the voltage what we got is high voltage, but in our house the different appliances have different requirement. For example, the mobile charger, the TV unit, they don't require too much voltage. So here they are, small transformer are used to convert high voltage to low voltage. So transformer is a device which can change a high alternating voltage, which means at low current, to low alternating voltage, which is at high current, and vice versa based on our requirement. So where we use it? We use for electrical power transmission from power station to our house, industries, and also to regulate the voltage for proper operation of the different electrical appliances. So now let's understand a bit detail of the transformer. So how the transformer structure look? So if you look the transformer structure, they are mainly the primary coil, which you see here, and it is written as a VP or NP to denote the primary part, and then there is a secondary coil which is here, and we write as a VS and NS, and there is a load which is nothing but a output. Okay, remember we are giving this main source from the primary and we are getting the same result in the secondary. So the structure of transformer is basically made of the two coils, primary coil and secondary coil, which are wrapped around on a laminated soft iron core. Okay, and the number of turns is fixed, like depends on your requirement. You can change also. So more will be the turn, the more will be the voltage supplied. Okay, so here we are using the laminated soft iron core, okay, which are thin sets. And why we use, I explained you, because it's easy to magnetize and demagnetize, which makes sure that magnetic flux linkage change between the two coils, and then it can induce the electromagnetic induction in coil B. So what happened when the primary coil is connected to alternating voltage? input Vp, a varying magnetic flux is generated in the soft iron core that induce the EMF in the secondary coil, and this voltage is called output voltage. Since circuit is closed, obviously if induced EMF is generated, it will give you induced current. So here there is one formula which is very important, which will tell you about what is the relation between the voltage and number of turns. So what is the relation we have? The relation what we have is basically Vs by Vp is equal to Ns by Np, and this is number of turn. Okay, please write it down in your notebook. This is very important formula to solve all kind of problem in the transformer. This is also called turn ratio. Okay, so this has given you that if you have the high number of turn in secondary, there will be high voltage. If the primary coil have high number of turns, it will be high voltage. So based on our requirement, we have two kind of transformer. First, a step up, and second, you can say step down. So step up and a step down is basically the concept in the secondary, means output. Okay, if the voltage is high in the output, you will say step up. So high voltage means low current. We are going to discuss in just a couple of minutes. What does it mean? Then step down, the output voltage will be low and the current will be high. Okay, so based on the equation what we have discussed, that if the current is the voltage is very high in the secondary, it means what? Number of turn will be more. And similarly in step down, just reverse this, that if the primary voltage is more than the secondary, it means the number of turn will be more. And from where we got this equation, let's discuss this part just now here. So what we know, that if you have, there's no loss in this transforming the energy from this side to this side, means from primary to secondary, right? It means whatever power is in the primary coil, so power in the primary coil will be equal to the power in the secondary coil, right? So I'm just writing short, power in the secondary coil. So what is the power in the primary coil? You can write P is equal to Vi. So Vi, right? P is equal to Vi. So power in the primary coil means what? PV IP is equal to what I should write? Vs Is. So this is the one equation what we know. From this data, what is clear, that Vs by Vp is equal to Ns by Ap. So you can arrange this part. Vs by Vp is equal to what I should write? Ip by Is, and so it will be equal to your Ns by Np. So this is the data what we have got if you combine this equation and this equation. So if I want to know that how much voltage is more, so can I say that Vs will be your Ns by Np into Vp. It means whatever the turn ratio we have, that multiplication will be with the primary voltage, you will get this answer. So what does it mean? That if you look this equation very clearly, if you look this clearly, it means what? If you have more Vs, right? Vs will be Vp, then what? It means your Is will be less than the Ip. And this is what we are going to discuss in the step up and step down transformer. That in a step up, if the secondary output voltage is more, it means the current will be less. And this is what I was discussing you here, the third point. So let's recapitulate again. What is the step up transformer? The output voltage will be more, so number of turn will be more, right? And from the equation what we have just now learned, that Vs by Vp is equal to your Ns by Np is equal to Ip by Is. So this voltage and current, they are reverse. So it means the current should be less in the secondary than the primary. Why it is important to understand this part? just now we are going to discuss that when we discuss about the power loss. Okay, so to make sure that it is highly efficient, the power supply to the primary should be equal to the power supply to the secondary. So efficiency, if you want to know what will be the efficiency formula, efficiency formula will be the output power, means how much it is given out, output power divided by input power multiplied by 100. So if you have output power, input power is equal, it means you will be this transformer is working as 100%, which is not possible in our actual scenario. Let's see some of the question what we have just now learned based on that. So this is the circuit shown it here. Okay, explain briefly how transformer work. So just now we have discussed transformer is basically work on the based on the electromagnetic induction, right? So you can write this part first, that it depends on the electromagnetic induction, where it's difficult to write, so I'll just say where what happened, the alternating current in the primary coil induces a varying magnetic field in the soft iron core, and so which create a alternating induced EMF in the secondary coil, which generate induced current. So we can see the current in the secondary coil now. Now let's see question number B. Assuming the transformer is 100% efficient, complete the table below. 100% efficiency means what? Just now we have discussed that power in will be equal to power out. What is in? It is your Vp Ip is equal to Vs Is. So based on this data they have given you Vp. So let's put it is the 250 into Ip. What is Ip you have? Is it Vs? Okay, this is Ip, right? It's a 2 is equal to Vs, you don't know. Is they have given you 40. So based on that, so oh no, I have written here 2. This should be just Vs, right? So if I want to know what is the Vs, yes, so Vs will be 1 minute, I cannot write, so sometimes difficult to write on the touchpad. So Vs will be your Vp Ip divided by Is, which is the 240 into Ip is your 2 divided by how much we have 40. So this will become your 6 to the 12 means 12 voltage. So I can fill here it will be 12 voltage. Now they are asking you what is NP. So based on the equation what we have learned, that Vs by Vp is equal to Ns by Np. So if you solve this part, Np will be your Vp into Ns divided by Vs. So what is your Vp? 240 into Ns they have given you 50 divided by Vs, just now we got 12. So 12 to ja 2. So if you solve this it will be 1000 turns. Okay, so C is done. This will be your 1000 turns. Is this transform is a step up or step down? So what we have learned, in a step up transformer the number of turn will be more than in the primary. So now if you compare, the primary is your how much turn? 1000 turn, and the second is 50 turn. It means what? Since here Ns is less than the Np and also the Vs is less than the Vp, it means what? We are decreasing the output. It means it will be your step down transformer. Step down transformer. Is it clear how to figure out? Now can you try to solve question D? Please pause the video and try to solve this question and let me know how many of them is got correct. I hope you got the answer. So the transformer used in experiment is actually non-ideal, obviously, because there will be some loss. So it is found that when primary current is 2 milliampere, secondary coil is 30 milliampere instead of the 40 milliampere. Okay, Assuming the secondary voltage is the same as that calculated, calculate the efficiency. So efficiency means what? Just now we have discussed, whenever you think efficiency, okay, it means what? How much is out divided by how much you have given in. So can I say power output, power input into 100, how much is out? V, P is equal to VI, so Vs by Is divided by Bp Ip. So Vs was by 12, Is was here based on this data 30 instead of 40, so 30 milliampere. I'm not writing milliampere because this is anyway going to cancel out, divided by 240 into 2 milliampere. So cancel out, this will be 15, this will be 20. So and obviously if you want to show in percentage, you have to multiply with the 100. So if you solve this part, you will get around 75% efficiency. Okay, so I hope you understood this part. If you have not understood, let me know in comment box that what was the difficulty you found it. So now let's move about that how the transformer basically help to transmit electricity to our house. So obviously you know that electricity generated is power station, and power station, the electricity generated in a huge amount and very high voltage. Okay, and from that it go to the railway station, to the shop, to the industry, to our house. So they are obviously modified by different transformer. So during the transmission, the one problem what is that whenever the current is going, okay, there will always some heating effect, obviously, because when the current go, the electron are in the wire and which find the resistance is there, and that's why it cause the leading that will lead to the heating effect. So based on this formula, if you remember that P is equal to I square R. If you can reduce R or you can reduce I, in these two process, if you reduce the either the resistance or the current, what will happen? The loss of power. So this is the formula of whatever we have getting loss. So loss of power can be minimized. Okay, so how to minimize the resistance? Resistance depends on the diameter. So you should use the thick cable wire, because if you remember the formula, resistance is inverse proportional to area. If area will increase, resistance will decrease, right? So I can use a thick wire. So remember, if you look that cable which is going from the transformer to the house, it is little thicker, but you cannot use so many thick soil. It is not possible using very thick oil for the long cables. It's very dangerous, and also the construction cost will be very high. So what other alternative we can use? We can use that the magnitude of current following to the wire, because it is I square, that we can minimize, right? So why not you minimize the current? Okay, because if you look, this is the square, so it will be greater amount of the power will be lost, can be minimized. So you decrease the current. How we can decrease the current? Just now we have learned that the step up. In the step up, what happened? The NS is more, Vs is more, but the Is is less than the Ip. So in this process, what happened? Whenever you are transmission of the voltage happening, it is going via the step up transformer. Okay, and then when it reached to our house, okay, the step down has been worked, which transform further to the high current. So I hope this is clear now, that why the transmission is always happen with the high voltage, means via the step up transformer. Okay, which further step down transforms this further to the requirement of whatever you have in our normal house. It is a step down. So if this is the normal question, like from power station to our house, by which mode the electricity go, it always remember it is going via the step up process. Because what purpose? So that the current will be low and the voltage will be high, and then a step down will come in the picture, which reduce the voltage for the suitable purpose in whatever is required in our household, and for also for save of electricity. so it will be safer part. Now let's see some of the question based on what we have just now discussed. That a power station with output power is this at this much voltage is connected to the cable of factory. Resistance they have given you. Calculate the current. So P is equal to VI. So I will be your P by V. What is P? You have remember kilowatt, right? Kilo means 1000, 10 to the power 3 divided by 20 into, I can write 10 to the power 3 just for easy calculation. So this is your 5. So 5 will be your ampere. So answer your 5 ampere. Now what is the power loss? Power loss, just now we have discussed that P is equal to VI. So power loss will be P output V into I. So I will be your P output divided by V. So what is P output you have? It is your 10 kilowatt, sorry 100 kilowatt divided by voltage, which is just now we have written. So no, so just now we have already solved the current, so current is done. No, this is the power loss. So power is equal to P is equal to VI. So I will be V square I square. If you remove this, it will become your I square R, because they have given you already resistance. So just put the value what I got the current here. So this is unnecessary. I was repeating the same part. So this is the part 2. Okay, let's clear it out. This is the part 2. So I got how much? 5 square into 5. So it will become your 125. What is loss in this process? So account of power loss. So it means whatever is power is lost, how it is lost. So power is lost mainly by the thermal energy. Okay, so I hope you understood this part, and in next video I'm going to talk about little bit more question from the transformer which has been asked in O-level. Let me know how this video you found. I hope it will be really help you to understanding the transformer related question. So thanks for watching, and share with your friends so they will also get benefit. Thank you.